So for day 2 of 8.4, we're going to talk about inequalities. But before we do that, I want to take a second and just have a short little warm up. So go ahead and pause the video and try numbers 1 and 2 on your own, and then I'm going to quickly go over them. So for number 1, because you do not have a log on both sides, you do have to rewrite it in the Hart method. So you would get 216 to the 4/3 equals x. If you take the third root of 216 and then raise it to the fourth, that's going to give you your x value. Well, the third root of 216 is 6, and 6 to the fourth is 1,296. On number 2, because you have a log on both sides, you're going to end up dropping the log. So you're left with x squared plus x, no, let me try this again, x squared equals negative x plus 12. At that point, you had to get it on the same side. So I moved everything over to the left. And if we factor, you would get 4 and negative 3. And if you solve, you get x plus 4 and x minus 3. In this case, x would equal negative 4 and positive 3. If you check both of those, they actually would both work. For 4, you'd get 16 over here. And over here, you would end up getting 16. Sorry, you would still get 16. For 3, negative 3, nope. For 3, gosh, these were negative. You still got positive 16. For a positive 3, you would get 9 over here, and you would also get 9 over here, so you're good to go. Okay, again, they're both positive. If either one of those answers gave us a negative, we would have to cross them off. So let's talk about the key concepts for today. Okay, so you're going to start out with logarithms, and then you're going to rewrite it as exponential functions. I want you to notice this really quick for me, though. Okay, typically, when we use the Hart method, we would go b to the y equals x. The problem is that when you use your inequalities, in order for them to be the same, you need to go b to the y equals x the reverse way. Okay, otherwise you have to flip your inequality. All right, so again, the next one's b to the y equals x again, but we have our inequality. So we can write b to the y and keep our inequality the same that way, or you can write b to the y and always flip your inequality. Okay, I'm going to do a little bit of both, and you can pick which one you prefer and then just roll with it every time. So if we look at number 1, okay, and I'm going to do it by just flipping where they're at so the inequality stays the same. Okay, so what's going to happen is we're still going to think about it as the Hart method. So we have 3 to the negative 4, but then instead of putting equals x to the right, I'm going to put x to the left and keep my inequality the same. So then from here, I just need to know what 3 to the negative 4 is. Well, remember that's really 1 over 3 to the 4th. And 3 to the 4th is 81, so it's 1 over 81. On number 2, there's less to think about with these inequalities because you have a log on both sides. And when you have a log on both sides, you can drop the log and you're left with just 4x minus 6 is greater than 2x plus 8. So we subtract 2x and get 2x, add 6 and we get 14. And then divide by 2 and x is 7. Remember, a big thing with inequalities, and we talk about this all the time, if you multiply or divide by a negative, you flip your inequality. So again, you always want to check your answers. On the last one I didn't, but it's a positive, so we're good. We want to make sure that when we plug it in here and here that it works, and they would. you'd get 28 minus 6, which is 22, so we're good. And you would get 14 plus 8, which is still 22, so we are good there as well. Number 3. For this one, I only have one log, so I need to rewrite it. So we have 5 to the third equals 4x minus 3. But remember, in order to keep the inequality the same, we need to put 4x minus 3 first. So we can continue solving. 5 to the third is 125. If we add 3, we get 128. Divide by 4, and x is less than 32. Make sure you think about it. If we plug it in, we get 32 times 4, which is going to be a really big number, minus 3, which is going to stay positive. Number 4 is done similarly. We only have one log, so we need to rewrite using the heart method. So we have 2 to the fourth is technically greater than 3x plus 1. Okay, we just keep it the same. It's the less than sign because we rewrote it this way. So we have 2 to the fourth, which is 16. So 3x plus 1 is less than 16. Subtract 1, and we have 15. Divide by 3, and x is 5. Again, just mentally check. If I plug it in, we'd get 16, which is positive, so we're good. Last two. Number 5, we have log base 3 on both sides, so we can just drop them. We're left with 3x minus 4 is less than x plus 1, and we solve. Subtract x, we get 2x. Add 4, we get 5. So x is less than 5/2. Number 6, also the same when it comes to having log on both sides. This has log base 5. So because it has log base 5 on both sides, we can drop them. You're left with 12x plus 5 is less than or equal to 8x plus 9, and we can solve from there. Subtract 8x, we get 4x. Subtract 5, we get 4, and x is less than or equal to 1. Again, you should always check your answers. When we plug in 1, it'll definitely be the same. It'll both be positive. If you plug in 5/2 in number 5, you would end up getting a positive 3.5 for both of them. So you get positive, so we're good on that as well.